Hi, my name is Mama Miracle binti Mama Akhiruddin.
Hi, Assalamualaikum. My name is Adin Hasana binti Zainab. You can call me Adlin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Samsul.
Introduction to Statistics. During a survey, we may face the problem of having too much data. The difficulty occurs when we try to answer questions such as how do we deal with large amounts of data, and what we will get from data analysis. Thus, statistics is a method that can help us to solve these problems. So what is statistics? Statistics is a study of making sense of data. Statistics represents scientific procedures and methods for collecting, organizing, summarizing, presenting and analyzing data. Statistics is a set of concepts, rules and procedures that help us organize numerical information in the form of tables, graphs, and charts. Statistics also helps us to understand statistical techniques and underlying decisions that affect our lives and well-being and then make informed decisions. There are two types of statistics. First, descriptive statistics. Second is inferential statistics. Descriptive statistics is methods of organizing, summarizing, and presenting data in an informative way. Inferential statistics is the methods used to determine something about a population on the basis of a sample.
What are population, sample and data?
A population is any entire collection of people, animals, plants or things, such as the distribution of students of University Kuala Lumpur, the favorite flavors of ice cream and more. A sample is a group of units selected from a larger group such as the distribution of electrical engineering students from University Kuala Lumpur, the distribution of marks of 40 students in a mathematics test. Data is a collection of information, either in the form of facts or numbers. Data can be categorized into two types, which are quantitative data and qualitative data.
What are applications of statistical concepts?
These are the example of applications of statistical concepts in the business world. In this topic, we also learn about grouped and ungrouped data, and also measure central tendency and dispersion, and how to sketch the graph.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Samsul, and today I would like to present to you about ungrouped data. What is ungrouped data? The data given as individuals point in values or number. For example, 1563 and so on. This kind of data can be represented in many ways. For example, pictograph, line graph, bar chart, and pie chart. Let's look at the next slide to give you a very detail about this kind of representation of data. Let's look at the example of data about score of the students, which we can use it as example of data. So this kind of data can be represented in pictograph. Pictograph is a representation of data using images or symbols. As you can see here, the data about the score of student represented by the emojis, smart emojis. For the one smart emojis, it represents 10 students. What are the advantages of pictograph? It's help in visually formatting statistics, and it's also make our data very interesting and easy to understand. This kind of representing are very useful for representing a large amount of data. This type of data usually used for representing a data for kids or students so that they could easy to understand and interpret the graph of data. Let's move to another example of representations, which is line graph. Line graph is type of charts used to show information that change over time. First, as you can see here, on the horizontal axis, which is known as x-axis, which represent you about the score of the student, and for the y-axis, or we know as vertical axis, represent the students. So we just plotting the data on the graph and just connect this kind of points, and it will give us the line graph. This kind of graph give us about trend line, which is whether it is uptrend or downtrend. This kind of graph usually used when it comes to show us about increasing or decreasing numbers. For example, the data about the COVID-19 cases in Malaysia. We can see that the trend line of the cases, whether it is increase or decrease. Let's move to another example, which is bar chart. Bar chart is another common method for graphically representing nominal and ordinal scale data. One bar is used to represent the frequency for each category. The bars are usually positioned vertically with their bases located on horizontal axis of the graph. Let's look at our bar chart. For the horizontal position, we can see that it shows us the number of the students, and for the vertical position, it represents the score of the students. Let's move to another example, which is pie chart. Pie chart is an effective way of displaying the percentage breakdown of the data by category. It is useful if the relative sizes of the data components are to be emphasized. The pie chart also provides us an effective way of representing ratio interval scale data after they have been organized into category. Let's look at our pie chart. For our pie chart, we can see the categories of each component, which is the score. As you can see, the yellow one, which represent the student who got A, and for the white one it represent the score of the student who got A minus. For the purples, the student who got B plus. The green one it represent the score of student who got B, and the last one is the blue one, which represent the student who got C. So it is easy for us to interpret whether which data is the largest and the lowest. So we can see here, the pie chart also can be represented in percentage. So that's all from me. Thank you.
Quick chat 1.1. Question 3. So this question is for example for presentation of ungrouped data. Okay, let's take a look at the question. An entrepreneur produced clothes in 4 sizes, which are S, M, L, and XL. Given that 24% from his yearly production was S size, half of the balance was M size, and the number of L size clothes produced was triple that of XL size clothes. Sketch a pie chart to present this information. Okay, as we know, this question asks to sketch a pie chart. But before we can sketch a pie chart, we need to list down all the data from this question in order to sketch a pie chart. So let's get the data from this question. So first, it states here that the production of S is 24%. So we write down S goes to 24%. Alright, now it said that half of the balance was M size and the number of L size and XL. So that means balance from 24 is 76%. How we can get 76% is by 100%. 100% minus 24%. Then we will get 76%. So this one is the balance from the production of S. So 76% is equals to M plus L plus XL. Alright, so here we have 24% for S, 76% for M plus L plus XL. So if we add these two, we will get 100%. We know that sketch pie chart, we need to have the data in the pie chart overall is 100%. But in this question said that for M size, it is half of the balance. That means we need to divide 76% by 2 in order to get value for M. So 76% divided by 2 will get 38%. So this one for M. We write down here M equals to 38%. Alright, right now we have S and M percent. So now we need to find for L and XL. How to find for L and XL? In this question, it states that L size clothes produced was triple of XL size clothes. So that means L is equals to, so this one that means that L is equals to triple XL. So in order to get the value of L and XL, we need to create a new equation. So the new equation will be like this. L plus XL equals to 38%. How we get 38% for L plus XL? This is because, as we can see here, 76% equals to M plus L plus XL. Since in order to get M, we already divided by 2. That means this value we divided into half, and M will equal to 38%. So the rest also 38% since it is equal divided into half. So for L plus XL also 38%. So we take a look at the statement back. L is triple XL. So we just replace L with triple XL. So the equation will be like this. 3XL plus XL equal to 38%. Alright, so now we sum up. We will have for XL equals to 38%. And to get the value for XL only, we need to divide 38% with 4. So XL equals to 38 over 100 divided by 4. So XL will be 9.5%. So now we already have the value for single XL. So XL equals to 9.5%. Now we only need to find the value for L. So how to find for L? We already have the value of XL since it said that L is triple XL. So we just need to multiply the percentage of XL with 3. So for L equals to 3 times the percentage of XL, which is 9.5%. So L will get 28.5%. Alright, now we have get L 28.5%. Since we have all the data here, we can sketch our pie chart. Alright, so to sketch pie chart, we need to have a circle first, and then we list down first the percentage that we already get from the question. So in this pie chart, we need to create for the produced clothes in 4 different sizes, which is S, M, L, and XL. So for S, we have 24% of produce. M, 38%, L 28.5%, while XL 9.5%. Alright, now we need to sketch the pie chart. So for 24%, we need to make a size that valid for 24% of pie chart. So for example, like I'm doing like this. So this one could be the valid one, could be the valid size for 24%. Okay, next we go for 38%. But remember, 38% we need to have equal size with L and XL. This is because these two equals to 76%, which is balance from the S. And we already divided the balance with 2. So for both M and L plus XL portion, we need to be equal. Alright, so we just do it like this. Alright, now it looks equal. So this one will be for M. And for L and XL, we know that XL is the smallest one. So we just made the smallest one, then we will get for L partition. So for sure, 9.5 will be like this one. Alright, so this one for L, this one for XL. Now, in order to make it look different and easy for us to differentiate between S, M, L, and XL, we can shade it with different colors or label it. But today, I would like to label and shade this chart. Okay, so for S, I will shade like this. Okay, and then label as 24%. So we go for M like this. Alright, we go with yellow color. Okay, and then we label it as M with 38%. 38%. Alright, now we go with L, 28.5%. Like this. Alright. And label also with L, 28.5%. So the last one will be, okay, it will be XL. So for XL, I would like to do a little polka dot here. Okay, like this. Alright, and then now we can label it as XL equals to 9.5%. 9.5%. Alright, now our pie chart is done. So this is how to sketch a pie chart. Thank you. Measure of central tendency and dispersion for ungrouped data. So today we are going to learn about this topic. First, we need to know flow of the topic. The first one, introduction to measure of central tendency and dispersion. Second, explanation about mean, median, mode, range, and standard deviation. And the last one, of course, example. Let's go to introduction. Introduction to measure of central tendency and dispersion. First, measures of central tendency are the measures of average that show the central location of data distribution. And there are three types of central tendency, which are mean, mode, and median. Measures of dispersion are the measures of the degree of dispersion to determine how far the values of a set in data are scattered or spread out in its average value. And there are few types of measure of dispersion, such as quartile, decile, percentile, mean deviation, variance, and standard deviation. Alright, did you know how to calculate mean, median, mode, variance, and standard deviation? Okay, let's go and take a look at it. So, the first thing is mean. Mean is the sum of all the values in a set of data divided by the number of values. That's mean, if we have a data, we need to sum up all of the values and then divide it by the number of values that we have in that particular data. And if we take a look at the formula, it's given that formula for mean, x bar equals to summation of x divided by capital N, where summation of x equals to sum of all the data and capital N equals to number of values of the data. Now we go to the example. Read the question first. The systolic blood pressure of 7 middle-aged men were as follows. As we can see, in the set of data that were given, it consists of 151, 124, 132, 170, 146, 124, and 113. As we count, it has 7 number of values. So as we know, the formula for mean is summation of x divided by capital N. So we need to sum up all the values and then divide it by 7. So 151 plus 124 plus 132 plus 170 plus 146 plus 124 and plus 113 divided by 7 because we have 7 numbers of values. And the mean that we get is 137.4. Next is median. Median is the value located at the center of a set of a data. The data need to be arranged in ascending order to determine the median. So basically, median is the middle value in a set of data. But to get the median, we need to arrange the data in ascending order. As we look at the formula, there are 2 different formulas. This is because median is divided into 2 numbers, which is odd and even. So, for data with odd number values, we need to use capital N plus 1 divided by 2. For data with even number of values, we need to use capital N divided by 2 and capital N divided by 2 plus 1. As usual, capital N is number of values of the data. Go to the example. The systolic blood pressure of 7 middle-aged men were as follows. We use the same data to make sure that we all understand the connection between mean, median, and all others things that we need to find. So, same data that used in this example, but we need to arrange in ascending order. This is because we want to find the median. So, we need to arrange it from the smallest to the biggest one. It's stated here that the smallest one is 113 and the biggest one is 170. So, we need to arrange it from smallest and the biggest. And here, I have arranged the data in ascending order, as you can see. So, for this data, we know that it is odd number. So, for odd number, we need to use the formula that capital N plus 1 divided by 2. So, here we have 7 plus 1 divided by 2. We will get 4. 4 is not the real answer. It's not the final answer. We need to determine where is 4 located in the arrangement. So, here, after we determine where the 4 is, we know that the median is 132. Then we go to mode. What is mode? Mode is the value with the highest frequency in a set of data. Basically, this one, we know that the mode is the most we can see in the data. Okay, example for mode. Still the same question and the same data. So, like I told, mode is the most frequently we can see in the data. So, in this data, we can see that there were 2 individuals that have same systolic blood pressure, which is 124. So, that one is the most frequently that we can see in this data. So, that means That is the mood for our question. Now, let's take a look at range. What is range? Range is the difference between the largest and the smallest value in the data. Range is the simplest one in this topic. Example of range. As we can see here, the biggest one is 170 and the smallest one is 113. Since the formula for range is biggest minus smallest, so 170 minus 113 and we will get 57 as the range. Alright, now we go to measure of dispersion. In this, we have mean deviation. Mean deviation is the average of the absolute differences between each value in a set of values and the average of all the values of that set. As given in the formula for mean deviation is summation of absolute value bar x minus x bar absolute value bar divided by capital N, where x is the data, x bar is the mean of data, capital N is numbers of values of the data. Example of mean deviation. Still, we use the same data and the same question. In this question, still we need to arrange the data in ascending order. So, as in the formula, we need to take each of the value and minus it with mean that we have got before this. And then we need to sum up all the total and divide it by 7. So, the mean deviation that we get is 15.9. Right, now let's take a look at variance. Variance is a measure of how much the values in a set of data vary from the mean of the set of the data. A larger value of variance indicates a greater dispersion of the values from its mean. The formula given is summation of absolute value bar x minus x bar absolute value bar squared divided by capital N. As usual, x equals to data, x bar equals to mean of data, and capital N equals to number of values of the data. Example of variation, we have arranged the data in ascending order, and as we can see, the formula for variance is the same like mean deviation, but we need to add squared in variance formula. So, x minus x bar squared. So that's mean the data minus mean squared and total up all the values that we get, then divided by 7. The variance that we get is 329.3. Now, the last one is standard deviation. Standard deviation is a measure that tells us how much the values in the set of data disperse from the mean. Ungrouped data use same formula with grouped data. This is because both use data of variance. So for the formula, square root of s squared. The last example is for standard deviation. As we know, the formula is square root of s squared, and we know s squared is variance. So the standard deviation is square root of variance. The value of variance that we get up before this is 329.3. We square root it and we will get 18.1 as our standard deviation. Alright, we have done for this topic. After this, we will go to the example or exercise.
Okay, now we go for the example question for the ungrouped data. Okay, we go for the question. The question, given the mean of the data is x minus 5, x plus 5, x plus 8, 3x minus 4, and 4x plus 7 is 12.2. So the question gives the value of mean, which is 12.2, and the question also for A want to know about the value of x, and for the B want to know about the variance and standard deviation of the data. To find the value of x, we can just use the main formula, which is sum all of x over n. We know that given value of mean is 12.2, so we can just write like this: sum all of x sum all of the data over 5 because the number of data is 5. 1, 2, 3, 4, 5 equal to mean. So using the mathematical calculation, you can find the value of x. X is equal to 5. And to find the variance, there are two methods. The first method is using the table. To using the table, we can just draw 3 columns for the y and y minus mean and y minus mean power of 2. Y bar is equal to mean. Why we use y? Because the x variable is already used in the equation, so we replace with y variable to avoid the confuse. So y bar is mean 12.2. For the y value is 0, 10, 13, 11, 10, 27. And y minus mean and this, and y minus mean power of 2 is we squared 12.2, we got this, 2.2, we got this, 0.8, we got this, and we sum up all of this, we got 374.8, and we take the total of this, we over 5, we over n 5, and we got the answer for the variance, which is 74.96. This is the first method using the table. For the second method, we can just write like this: 0 minus mean, 10 minus mean, 13 minus mean, and we power of 2 all of this, and we sum up is over 5, and the answer is same, 74.96, because it is the second method. Okay, for the question also, want to know about the standard deviation, the value of the standard deviation. We know that the standard deviation is s, and for the variance is s power of 2. So to find the value of s, we just square root s power of 2, which is square root 74.96. And we got the standard deviation for this question is 8.658. Okay, that's all for the example question for this topic. Thank you. Now I want to present about the group data, which is include histogram, frequency polygon, and Ogive. Okay. For the first, group data is the data that is organized and arranged into different classes or categories. For the presentation of group data, we will discuss how to create a histogram, frequency polygon, and Ogive. Before we plotting the graph, we need to construct the frequency table, which is using this formula. First, range formula, and second, class size formula. Now for the histogram. A histogram is a bar graph with no space between the bars. The height of each bar shows the frequency of data within the interval. The intervals of a histogram are of equal size and do not overlap. And this is the rules when we construct the histogram graph. The first, histogram are used to show the frequency of data, very similar to bar graph but use interval on the x-axis, not in the y-axis, and bars detached, not and have no space. Histogram has a title, and the histogram has two axes which are labeled. This is the explanation for histogram. Okay, next, frequency polygon. For the frequency polygon, the first is another common method for graphically presenting interval and ratio data. To construct a frequency polygon, mark the frequencies on the vertical axis and the values of the variable being measured on the horizontal axis as with the histogram, which is we plot the mark on the histogram graph to find the frequency polygon graph. If the purpose of presenting is comparison with other distribution, the frequency polygon provides a good summary of the data. This is for frequency polygon, and we move to the Ogive. Ogive is a graph of a cumulative frequency distribution. Ogive is used when we want to determine how many observations lie above or below a certain value in a distribution. First, cumulative frequency distribution is constructed. Cumulative frequencies are plotted at the upper class limit of each category. Ogive can also be constructed for a relative frequency distribution. This is the explanation for Ogive, and we move to the example. For the example data is the following table shows the scores of 40 participants in mathematics quiz. This is for the data for example. And now we use the data to construct the histogram graph. To construct histogram graph, we need to find the class boundaries, which is the 20 minus 0.5 and 24 plus 0.5, and to find the class boundaries, which is this is for the lower boundaries and this is for the upper boundaries, and we use that boundaries to represent the x-axis, which is this to construct the histogram, and the number of participants represent as y-axis. And this is for example for the histogram graph. You can look, and now we move to the next. Now for the frequency polygon, we also can use that data to construct the frequency polygon graph. But for the frequency polygon, we must find the midpoint, which is upper boundaries plus lower boundaries over 2, and we got that midpoint. Midpoint is represent the value between the interval, which is this and this. It all is the midpoint of the class boundaries. And as the histogram, same as the histogram, the x-axis is represent as the score, which is the class boundaries, and y-axis is represent the number of participants, which is this 303710. That is for the frequency polygon graph. And okay, we also can use that data to construct the Ogive graph. To construct the Ogive graph, we must find the class interval, because we must find the score before the current score, which is this 15 until 19. For the class interval, we find it 5, and for the score that we find is 15 until 19. So the number of participants is 0, and the upper boundaries of that value of that data is 19.5, and cumulative frequency is 0. We also must find the cumulative frequency when to construct the Ogive graph, which is 0 plus 3, and we got 3, and 3 plus 7 we got 10, and 10 plus 10 we got 20, and more until we got 40 participants. And to construct the Ogive graph, the cumulative frequency is represent as the y-axis, which is this, and the upper boundaries represent as the x-axis, which is this. And we got the Ogive graph, their flow, and the line is like the curve like this, the smooth curve. This is for the Ogive graph. Okay, and next, thank you. That's all for the explanation about the histogram, frequency polygon, and Ogive. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today, let's discuss about these questions. Let's read the question first. The daily wages of the employees of AA Sdn Bhd are follows. As you can see here, it is the daily wage. The number of employees. Determine the mode and median of the data using a graphs. To determine a mode, what kind of graph that very suitable? So I guess that we need to do the histogram. So to do histogram, we need to do a table. So Let's do the table. Frequency, which is the number of employees, and last is lower boundary. Okay. Okay, just rewrite the data given. And the frequency, which is the number of employees. So to get the lower boundaries, we need to add this 37 and 38 and divide by 2. So we get it as what? So for the lower boundary of this, we need to add the previous number, which is 34, with the 35 and divide by 2. So we get 34.5 as the lower boundary. And same goes with the other data. So after we finish do the table, we can do the histogram. Based on this information, we can do the histogram, which is like this. As you can see, this is the lower boundary for the x-axis, and for the y-axis is frequency. So after you done do the histogram, to find the mode, you need to connect the edge of the, this is the highest frequency of the data. So we just connect this edge with this edge, the lowest. Yes. So we connect it. Same goes with the next part, which is this one, this edge. The intercept between these two lines will give us the value of the mode. So we just project to the down to get the values. Be careful. So this is the mode of the data. So as we know that for every, so for this range the value is 3, so 10. So for every this one, it will value 0.3. So for the 3, so we just multiply with 3. We got 0.9. So add the value. So the mode will be 40.5 plus 0.9. So for the answer is 41.4. This is the value of our mode. So let's move to another things, which is median. How to find median? To find median, we need to do Ogive by using graph. So let's do the table for Ogive. First thing first is daily wage. Cumulative frequency. frequency, and last upper boundary. So you need to be careful when you rewrite the data given so that you will not be careless. Let's do the frequency first, which is 4, 8, 12, 3, 3. So for the cumulative frequency is the total of frequency. So first, we do like this, which is 4, then we got 4 plus 8 is 20, 12, then add 12, so we got 24, and 27. Next is 30. For this data, we show us the total of number of employees. For the upper boundary, same goes with the lower boundary. So we just add these two of number and divide by 2. So we got it as 37.5, 40.5, 43.5, 46.5, and 49.5. So before you forgot, for the Ogive, we need to start with the 0, but our data have given that it start from 4. So you need to do one range of, you need to add one range of data, which is 34 until 32. So for the cumulative frequency, frequency is 0 and cumulative frequency also 0. So for the upper boundary is 34.5. Yes. So after we get all this data, this kind of data, we need to interpret it into the graph. So let's see our Ogive graph. As you can see here, this is the x-axis, which represent the upper boundary, and for the y-axis represent the cumulative frequency. We just plotting on the graph by using the data that given, which is cumulative frequency. So we have sketched the Ogive. To get the median, we need to divide the total of number of employees, which is 30 divided by 2. We got 15. So find 15 on the y-axis, which is here. So we just project here to the graph. Be careful. Okay. So we just project down. So this is our median or second quartile, Q2 or median. So as we know that for every one distance between the line, it is 0.3. So there are 4 box. So times 4, we got 1.2. So 40 for our median is 40.5 plus 1 of 1.2. So we got 41.7. So this is our median and this is our mode. The value of our mode 51.4 and for the median is 41.7. So we rewrite it on the questions. For the mode is 41.4 and for the median is 41.7. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to present to you about the calculation in group data based on these questions. So, the following table shows the bonus point earned by customer at KB Mall. So, from this data, we can find that the mean, median, mode, quartile, range, variance, and standard deviation. To determine the value of mean, median, and mode, we need to do the table, which is the table will give us value about midpoint, cumulative frequency, class boundary, which will be used in the formula. So what is mean? Mean is the average of the data. So what is the formula? The formula is summation of fx over summation of f, which is frequency, the number of customer. So we just substitute the value that we already get from this table, which is this fx. We got 1599 over 70, this one. So the answer is 22.84. So this is the mean of the data in this question. Let's move to the next thing, which is median. What is median? Median is the half of the data. So to find out the median, so we will use the formula is the lower boundary plus and the total of frequency over 2, because we want median, which is half of the total cumulative frequency, minus by f times c over f. F median, f of the median. So just substitute the value. First, this is we need to find the n, as we know that n is 70. So we know that 70 over 2 is 35. So from this we can refer the cumulative frequency were 35, which is at this, right? So we take the lower boundary of this cumulative frequency, which is this, (22.5) plus minus 33 over 13, which is the frequency of the median. Then this is the frequency previous, cumulative frequency previous of the median. So C, how to find C? To find C, we just minus the boundaries here, 10.5 minus 4.5, so we got 6. So it is 6. Just use calculator to find out the value, which is 23.42. So this is the value of our median. So let's proceed to the mode. As we know that mode is the data that have the highest frequency. So for the mode value will be in this range because the highest frequency is 20. So let's calculate it. So the formula is the lower boundary of mode plus d1 over d1 plus d2 times C. So just substitute the value. So as we know that this is the what we call the mode range, so we just refer this and then we put the lower boundary of this, so 28.5 plus 7 over 7 plus 16 times 6, which is the C that we already calculate. So the value for the mode is 30.33. So that's the value of the mean is 22.84, the median is 23.42, and for the mode is 30.33. Okay, let's calculate the other value, which is the quartile. So to find out the value of quartile, we need to do the table also, which is the table is same with just now. So how to find the quartile? First, we found out the first quartile, which is Q1. What are the formula of first quartile? The formula is LQ1 plus n over 4, because it is quartile. Quartile means quarter. So 1 over 4 minus the cumulative frequency previous over the frequency of the Q1 and times C. So how to know this? First, we need to divide the total frequency with 4. So 40 divided by 4, we can get is 17.5. So search where is the 70.5. So in this range. Okay, so we took the lower boundary of this range, which is 10.5 plus minus with the cumulative frequency previous, which is 7, over the Q1 frequency, which is 12, and for the C we got just now is 6. So just calculate it. So the value is 15.75. So the next thing is third quartile. If you know that just now we calculate the median. Median is also known as second quartile. Quartile or Q3. The formula looks same, which is LQ3 plus N 3 over 4, because it is third quarter of the total frequency, minus previous cumulative frequency times C over FQ3. So to find that, so we need to divide 3 over 4 times with the 70. So we get 52.5 plus, so 52.5 is this string, right? Okay, so the lower boundary for the third quartile is 28.5. So the previous frequency, which is 46, times C, which is same, 6, and over the FQ3, which is 20. So calculate it, and we got the answer is 30.45 for the third quartile. Next, we found the range. What is range? Range is the highest data minus the lowest data. So for our example, the highest data is 40 and for the lowest is 5. So just minus. So we got 35 for the range. Let's proceed on others thing, which is variance and standard deviations. So we will use this table which gives us information based on the formula of variance. So what is variance? So for the variance is formula is summation of x minus mean squared times f over the summation of frequency. So when you do the table, you already get the total summation of this x minus mean. So we just substitute from the table for the value. So we got 3.08 over 70. Okay, so the answer is 75.74. Next is the standard deviation. As we know that standard deviations is square root of variance. So when we get the answer, we just square root the answer of the variance, which is 75.74. So the answer is 6.70. So what we need to do is the table. So we just substitute the value that we need in the table, then we just calculate it, and then we get the summation of this thing that need in the formula of variance. So we just substitute the value that I already get from this table. So the answer is 75.74, and for the standard deviation is 6.7. So that's all from me. Thank you.
Question 11. So for question 11, it is example for measure of central tendency and dispersion for group data. So the following table shows the typing speed for 120 secretarial students. So as the table given, it consists of words per minute and number of students. Okay, based on the table, calculate the mean, median, variance and standard deviation. But before we can calculate all what the question want, we need to have a new table, or like we need to create a new table in order to get mean, median, variance and standard deviation. So the first table that we need to create is this table, a table that consists of frequency, midpoint, cumulative frequency, class boundaries and multiplication of frequency and midpoint. Alright, so here frequency we can refer to the number of students here. Okay, so we just copy the values and put in the table. So for midpoint we need to add the words per minute. So we need to add this range. So for the first row, we need to add 1 plus 10 and divided by 2. Then we will get 5.5 for first midpoint. So for the second one, 11 plus 20 divided by 2, we will get 15.5. And the rest is the same thing. Okay, now we will move to the cumulative frequency. So for cumulative frequency, it's a bit different from frequency. This is because we need to add a value from cumulative frequency with frequency. So for example, for this one, we just copy from the frequency, but for the next 5 row, we need to do this method. So for 45, here, how I can get 45 is from 30 from cumulative frequency, we plus with 15 from frequency, then we will get 45. And it is repeated for the next row, which is 88, 108, 118, and 120. Okay, got it? Okay, now we go to class boundaries. So for class boundaries, it consists of lower boundaries and upper boundaries. So this side is lower boundaries and this side is upper boundaries. Okay, so for lower boundaries, how to get lower boundaries? We need to use this number 1, 11, 21, 31, 41, and 51. So how? We just need to minus by 0.5. And for the upper boundaries, also we use these numbers 10, 20, 30, 40, 50, 60, which is plus by 0.5. Then we will get the class boundaries. Okay, now we go to fx, which is the multiplication of frequency and midpoint. So how I get this fx is by multiply frequency and midpoint. So for the first one, I multiply 30 multiplied by 5.5, then I will get 165. Same goes to the others. So for this table, there are 2 types of data that we need to calculate the total. So we need to calculate the total for frequency, and I have got 120. Then for multiplication of frequency and midpoint, I have got 2770 for the summation. Okay, now we have enough data to calculate our mean and median first. So let's go. Okay, this is how we calculate mean. So as you can see here, formula of mean is x bar equals to summation of fx divided by summation of f. As we know, we have got the value at the new table that we have created just now. So we just insert the value in the formula. So for summation of fx, the value that we get is 2770, and divided by summation of frequency, we get 120. So divided by 120, and the answer is 23.08. Sorry, my mistake. So the answer for mean is 23.08. Okay, now we go to median. So for median, the formula is m equals to lower boundary of the class where the median lies plus the total frequency divided by 2 minus cumulative frequency before the class where the median lies divided by frequency of the class in which the median lies, then times by class size. Okay, so for the lower boundary of the class where the median lies, as we can see here, it's lower boundary, so we need to take a look at this side only. Okay, for lower boundary of the class where the median lies is this one. So we put here 30.5 plus the total frequency 120 divided by 2 minus cumulative frequency before the class where the median lies, which is here, as you can see, 88. This is our median class, and before median class, the cumulative frequency 88. So we put here 88 divided by 20, the frequency of median class, okay, and then times by class size, which is 10. To get this class size, we just need to minus the upper boundaries with lower boundaries, then we will get the class size. So after we calculate all this, we will get 16.5 as the median. Okay. So now we go to the variance and standard deviation. Okay. So for variance, also we need to create a new table, which is important in order to get our values for variance and standard deviation. So this is the table that I have made for standard deviation and variance. So this table consists of x, which is midpoint, and then here we can see midpoint minus mean, and data minus mean. This one, data minus mean times by frequency, data minus mean squared, data minus mean squared times frequency. Okay, all this value I have calculated. So in this table, we need to get the total of data minus mean times frequency, the summation of it, and I get 1282.6. And for the next one, we need to have the total of data minus mean squared times frequency, and what I get is summation of x, or data minus mean squared times frequency, is 20,599.49. Okay, now we are done. So this value will be used in the calculation of our variance and standard deviation. Okay, now let's take a look at variance. So the formula for variance is s squared equals to summation of data minus mean squared times frequency divided by summation of frequency. So here we already have the data before this at the second table, which is 20,599.49 divided by summation of frequency, and we have the data also from the first table, which is 120, where we calculate it and we get 171.66. Alright, so now we go to standard deviation. So for standard deviation, the formula is s equals to square root of s squared. So we know s squared is variance, so we just need to insert the value of variance and square root it, and we will get the answer is 13.10 for standard deviation. Okay, that's all.